Hello everybody. Today we're going to talk about summarizing quantitative data with box plots and outliers. So besides serving as a measure of variability, the interquartile range is used as a ruler for identifying outliers. So how do we find outliers? Well, we're going to use the 1.5 times the IQR rule. So what we're going to do is we're going to call an observation an outlier if it falls more than 1.5 times the IQR above the third quartile or more, or then 1.5 times the IQR below the first quartile. So that is, lower quartiles are going to be Q1 minus 1.5 times the IQR, and higher outliers are going to be Q3 plus 1.5 times the IQR. Now, I know all these words don't make a lot of sense right now, so let's do an example. So example number 12, home run king. Here are the data on the number of home runs that Bonds, and I'm assuming this is Barry Bonds, hit in each of his 21 complete seasons. So we're going to identify the outliers in this distribution, and we're going to show our work. So in order to find our outliers, we need to find our 5-number summary, like our median, quartile 1, quartile 3, and we're going to go from there. So in order to do that, we actually have to put all of these numbers in ascending order, so from least to greatest. So we're going to go through this. I'm going to go through a little bit quicker because of time. So we have 16, 19, 24, 25, 25, and then it looks like we have 26, 28, and then we have 33, 33, 34, and we have another 34. We have two 37s. We have a 40, 42, and then it looks like we have two 45s. 45 Guilford. Hope we don't run out of room. Another 45, and then we have two 46s. Getting really close to the end here. And then we have a 49 and a 73. Now, I always tell you guys to try to make sure to recount and make sure you have 21 things. How do we know we have 21? Tells us we have 21 here. And if you recount everything, 6, 8, 10, 2, 4, 6, 8, 10. I have 21 items here. So I have all of my numbers. So what we need to do is, because there's 21 items, that means that we are looking for a number in the very middle of all these numbers. And that's going to be the 11th number. That means there'd be 10 on one side, 10 on the other. So what I'm going to do is I'm going to find the 11th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like this 34 here is our median. So here's our median. Okay, and then we now split it up into this half here and this half here. So what we're going to need to do is we're going to need to find the quartiles by finding the middle number. So when we're finding the middle number here, we're not actually using this median. It's not going to be included in our quartile finding. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items here. So we're going to be looking between the 5th and 6th number. 2, 3, 4, 5. So it looks like it's going to be between 25 and 26, which is 25.5. That's going to be quartile 1. And then we're going to look for the number between the 5th and 6th number over here on this side. 1, 2, 3, 4, 5. So it's going to be between 45 and 45, which is easy for us, is just 45. So now that we have all the quartiles, we can now find the interquartile range, the IQR, which remember is Q3 minus Q1. So we have 45 minus 25.5, which is equal to 19.5. Okay, so our interquartile range is 19.5. Now, we need to see if there's any outliers here. In order to do that, we need to do Q1 minus the 1.5 times the interquartile range. That's the name of the rule. Okay, and we need to do Q3 plus 1.5 times the IQR. So we have quartile 1, which is 25.5. and we are going to subtract 1.5 times the IQR, which is 19.5. Okay, which when you put in your calculator, you're going to get negative 3.75. So if anything is lower than negative 3.75 here, it is considered an outlier on the lower end. So we can see that we don't actually have anything below negative 3.75, so there's no lower outliers here. Okay, so let's see if there's any higher outliers. So we have Q3, which is 45, and we're going to do 1.5 times 19.5, which is our IQR, and we're going to get 74.25. Now, that means if you have anything higher than 74.25, that would be considered an outlier. But as you can see, there's nothing over here that is higher than 74.25. If we had like a 76 on here instead of a 73, 76 would be an outlier. But because there's nothing that falls outside of these ranges here, from negative 3.75 to 74.25, that means that there are no outliers. Now, there can be a lot of outliers, just this example doesn't have any. So just be careful. We'll see other ones that do have outliers in the future examples. So, it is important to identify outliers in a distribution for several reasons. The first one is the most common, that there was inaccurate data values put in, and it happens all the time. Like you're putting a whole bunch of numbers in your calculator, instead of a 33, you put a 3. Okay, that will probably show up as an outlier depending on what your data is. So it's very important that you look into outliers for that first reason. The second reason is that they can indicate a remarkable occurrence. Like you could see something crazy happen. Maybe number of pets somebody has, it would be like 200. Maybe they run some sort of clinic, but the average amount of pets that everybody else has is around 2 or 3 pets. So, I mean, this is really good to kind of like notice. Maybe you would include that person in your data, maybe you wouldn't. Again, depends on really what you're looking for. And you got to be really careful because part 3 says that they can heavily influence the values of some summary statistics. And if you guys remember our Bill Gates example, with him walking into the room and the mean salary jumping up to millions of dollars, that's a really good example to see how this can definitely influence your summary statistics. Now, I mentioned this earlier, a 5-number summary. And a 5-number summary is a distribution of quantitative data. It consists of the minimum, the first quartile, the median, third quartile, and the maximum. So there's your 5 parts. Minimum, Q1, median, Q3, and the maximum. Okay. So there's nothing really different here, but there is something different that we can do with this information. And that thing that we can do is making a box plot. And a box plot is a visual representation of a 5-number summary. Now you guys may have heard box plot, box and whisker plot. These are all different ways that we denote what we're about to do. So example number 13, how big are the large fries? So Ryan and Brent were curious about the amount of French fries they would get in their large order from their favorite fast food restaurant, Burger King. They went to several different Burger King locations over a series of days and ordered a total of 14 large fries. The weight of each order in grams is shown here. So we have all of these numbers, and there are 14 of them. Okay, so what we're going to do is we're going to make a box plot to display this data. Now, before we do, we're going to have to put all of these in ascending order and find our 5-number summary. Okay, so I had to go back and recheck my numbers because I missed a number somewhere in my last one. So just so you don't have to hear me listing all these numbers off a whole bunch of times, we have now checked our answers and we have put them all in order, and that's a 173 over here. So again, guys, super important to always make sure that you have 14 numbers and go back and check your answers, because if you do not do that, then you might actually end up having a problem later down the line. So now we have 14 numbers here, so we need to find the median first, so the number between the 7th and 8th number, because there's an even amount. So 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be the number between 166 and 167. So our median is 166.5. Okay, so now because we have 14, that means this side is broken up into 7 and this side is broken up into 7. So that means we're going to be looking for the number that is 4th on both sides. So 1, 2, 3, 4. So this is going to be our Q1. Do you see how it's halfway between? We have 3 here, 3 there, and then we have this side over here. So we have 3 and then 3. So 170 is going to be our quartile 3. And just because I didn't mention it, this is going to be our minimum, and this is going to be our maximum. Okay, so now before we actually make our box plot, we have to check for any possible outliers. So now that we have our 5-number summary, we're going to check to see if there are outliers by finding the IQR, okay, which is going to be 170, because remember it's Q3 minus Q1 minus 163, okay, and that's going to be 7. So now we're going to do Q1 minus 1.5 times the IQR. So now we have Q1, which is 163, and then we're going to subtract 1.5 times 7, and you're going to get 152.5. Then we're going to find Q3 plus 1.5 times the IQR. So now we have Q3, which is 170, plus 1.5 times 7, which is going to give us 180.5. Now, if you look, we do have a number that is less than 152.5, and that is actually 152, our minimum. So we do have one outlier. We don't have any outliers on the high end. So now what we're going to do is we're going to graph out our box plot. So because we have numbers from 152 to 173, I'm going to make a box plot. So I'm going to make a number line first, and it's going to start out from 150, and every 5 I'm going to do here. So 160, 165, 170, 175, and we don't have anything bigger than 175, so we'll just add it there. Okay, that just erased the whole line. Let's try that again. Okay, so now we're going to denote our points. So first of all, we have an outlier at 152. So we're actually just going to draw a dot there. Okay, that's supposed to denote our 152. Now, because 152 is our minimum, but it's also an outlier, we're going to have to start our box plot, our box or whisker, at 159. So our first line is going to be here at 159. And then we're going to have 3 more lines. We're going to have them at the quartile 1, which is at 163, slightly longer. Then we're going to have another one at our median of 166.5. And again, we're just kind of eyeballing here, guys. If this was on graph paper, it'd be a lot neater. And then we have our Q3 at 170. Okay, so this just made our box in the middle with our Q1, our median, and our Q3. And the last thing we have here is our maximum, which is going to be at 173. So we're going to draw another line. And then we're going to connect this box with the whiskers, and then we get our box plot. So again, our minimum's down here, but it's an outlier. That's why it's a point. So now we have our next number, which is 159. We have our Q1, which is here, our median, which is here, and we have our Q3, and then here's our maximum. Okay, so here's our box and whisker plot. And of course, we need to label this. We're going to call this weight of large fries. And we're going to make sure that that's labeled in grams. Okay, so according to the nutrition website, Burger King's large fries weigh 160 grams on average. Ryan and Brett suspect that their local Burger King restaurants may be skimping on fries. Does the graph in part A support their suspicion, and why? Now, if you guys look back at the graph, remember 160, okay, we can see that the first quartile is at 163. So we know that our first quartile is at 163. Now, why is that important? So the first quartile quartile, not quarter, is 163 grams. Now, because our first quartile is 160 grams, that means that 25% is under 163 grams, but that means that 75% of the fries were over 160 grams. So that means that they're not skimping. In fact, it seems like they're giving them more fries. So that's what we're going to write. So the first quartile is at 163 grams, which means that 75% of fries are over 160 grams. on average. So there, it seems like Burger King is not skimping on the fries. Okay. Now we have one more example of the day here. And before that, I need to warn you guys that box plots do not show gaps, clusters, or peaks. All you'll see is skewedness and where the 5-number summary is and outliers. So usually you'll see this in some form of question where it'll be like, well, which graph is not appropriate to show gaps, clusters, and peaks? And the answer to that is box plots. Because if you guys think about it, histograms can show gaps and peaks. Okay, there's an example of a histogram. So box plots cannot show gaps, clusters, and peaks. Now we do have one more example, and it's a little bit of a doozy, but most of the work is actually done for you. It's given to you in the form of these number summaries and the graphs you're about to see on the next page. So example number 14, which company makes a better tablet? So in a recent year, Consumer Reports rated that many tablet computers for overall performance and quality. Based on several variables, they gave each tablet an overall rating where higher scores indicate better ratings. The overall ratings of the tablets produced by Apple and Samsung are given below. Parallel box plots of the data and the numerical summaries are also shown below. So here's the numerical summaries here. Okay, we're going to be coming back to this. And then here are the parallel box plots. So we're going to compare the overall rating distributions for Apple and Samsung. And remember, when you're talking about distributions, you need to remember your socks. And remember, we're using comparative words here because it says to compare them. Okay, so our socks, remember that the first S stands for spread. So let's look at the spread here. So both for spread, both standard deviations, okay, and the IQR for the Samsung tablets is actually greater, okay? So if you look here, the Samsung tablet here has 6.74 to the Apple's 3.762. Goodness, can't talk. And here for the Samsung, the IQR is 11, and for the Apple, it's 3. So for the spread, what that means is that there's more variation in the Samsung tablets. So you can say there is more variation in the Samsung tablets. And here you can drop some numbers here. You can say that S sub x is equal to, what was it? For the Samsung, going back, we have 6.74 and 11. Then there are in the Apple tablets. And that was 3.762 and an IQR of 3. So if we really wanted to look into this, that means that Apple products, if the spread is smaller, that means that Apple products tends to have a more consistent rating. And that's what it usually means by spread, is that's more consistent. Okay, so outliers. The cool thing is we didn't actually have to look for outliers here. They're given to us right here in this graph. And you can actually go back to the data that they gave you to see exactly what those points are. And they look like they are their two lowest points, which are 73 and 76. Okay, so what can we say here? We can say that Apple has 2 outlier scores at 73 and 76, while Samsung has no outlier scores. Okay, so we're halfway through. So now C stands for centers. Okay, so if you look at the centers here, we can use both because remember there's two measures of centers. We have our mean and we have our median. Now, if you look, Apple has both higher mean and median than the Samsung tablets. Okay, so that's what we can say. Both the mean, which was 83.45, and median, which was 84, we can stick it right there, was better for the Apple tablets than the Samsung tablets. And remember, we like to stick those numbers in here. So we'll say that the mean, if I remember correctly, was 79.87 and the median was 83. Okay, so it wasn't that much higher of a median, but the mean here is definitely 4 more points. And last but certainly not least, let's talk about the shape. Now, if we look at the shape of these two graphs, we can see that there's like not a lot of information over here. These are giant tails, right? So we can actually see that these are skewed to the left. They're both skewed. So both distributions are skewed to the left. Okay. So this is what I mean for when I say compare the overall distributions of two things. You got to go through your socks. You got to use comparative words like more, has less, things like that. Okay, so we are actually done with today's notes. If you guys have any questions, you guys always know that you can email me or join me during the Google Meet. Have a fantastic day.